Now we are understanding the multi-dimension concept. So in the multi-dimension concept, what exactly happens here is we will have a fact table, and this fact table is surrounded by dimension tables. In the fact table, there will be two things. One is the dimension ID, another is the measures. Okay, so what are measures are any numeric values are called measures. Any numeric values. For example, sales amount is a number. It can be considered as a measure. Quantity is a number. It can be considered as a measure. If you have some number, a particular any value or any field which is defined as integer or numeric or date, this all can be considered as measures. And measures will always be saved in the fact table. Now, this will be surrounded with the dimensions, and each dimension has some characteristics. And these characteristics will be of type characteristic. So if you mention or maintain something as a numeric or an integer, you cannot save it in the fact table. You have like you cannot save it in the characteristics. Okay, so you cannot save it in the dimension. Dimensions always store characteristic values, that is like alphanumeric values. So it has to be the property itself have to be character. Even though you mention the numbers, even if you maintain numbers, you have to mention the data type as character. Only then it will go and fit in the dimension, otherwise it will not fit in the dimension. So dimensions are something which will have multiple fields in a table. So we have in this on the screen we have four dimensions, and each dimension has a particular category of fields. Each dimension has a particular category of fields. So for example, we have customer address details, our customer time code ID, so fiscal year, quarter, month, all these are related data. Or material ID, name, type, group, all these are related data. So this related data will be in a single dimension. So there can be n number of dimensions which are surrounded by fact table. Each uh, each software has a limit of these many dimensions. Okay, so a particular number of dimensions will be there. For example, in BW, we had 13 user defined dimensions and 3 standard dimensions, totally 16 dimensions. That's the limit of it. So similarly, each characteristic has its own dimensions. Each star schema has a particular limit of dimensions, and this is also called as star schema. This is multi-dimensional concept. In this multi-dimensional concept, if you have any doubts, let me know. And one more thing is, guys, like this material id. See, first material id is linking, this material id is generated by the system. Material id is linking this material dimension with the material id. Here also we have material id, here also we have material id. Then we have sales representation ID is linking this fact table with the sales organization dimension table. And then we have this time code ID. Time code ID is linking this time dimension with the fact table. Customer ID is linking the customer dimension with the fact table. So these all IDs are automatically system generated. And then fact tables is something which we are going to provide. So the multi-dimensional concept which we are talking about is common for all the data warehousing tools. And since, as we discussed earlier in this session, that HANA is something which was near to data warehousing tool, so it also had this. So first, our source tables are schema tables. These are called schema tables. The database tables that we have normally used in the normal ABAP are different from the schema tables. In the schema tables, when we access data from the schema tables, the first thing we access the data into is the attribute views. So an attribute view is equivalent to the dimension table in the star schema. So this cannot be considered as a standalone table to access the data. You cannot use this as a standalone table to access data. The attribute view has to be used in an analytical view. Analytical view is equivalent to the star schema table, multi-dimensional table. Now, what does a multi-dimensional table have? A multi-dimensional table has a fact table surrounded by surrounded by dimension tables. So, if you want to build an analytical view in the HANA Studio, we must have at least one attribute view, at least one fact table. There should be a not at least there should be there can be only one fact table, but in that at least one measure should be there. Measure. What do we mean by measure? The numeric values are considered as measure. The technical term in the HANA perspective is called measure. So numeric values can be stored in the fact table. Okay, fact table cannot store the characteristic values, and characteristic values are stored in the dimension table. Dimension table. So we have numeric values are stored in fact table and characteristic values are stored in dimension table. So without without creating a dimension table, characteristic values in dimension table. So the uh, dimension table is called fact table is a fact table. Dimension table is called attribute view. In SAP HANA, it is called attribute view. This is called attribute view. A dimension table is called attribute view. Dimension table is called attribute view. So this attribute view is what we have here. Fine. So we need to create at least one attribute view, and there should be at least one fact table. Only then we can create an analytical view. So let's create these things in the system now. Let's create it in a very simple way. So here we have the attribute views, analytical views. So attribute view is a combination of attribute view is a dimension table, and analytical view is a combination of fact table plus attribute views. So we can have a single attribute view also, and we can create a analytical view. But there should be a fact table with measures and attribute view. Attribute view is equal to dimension tables. Okay. So then we have something called calculation views. So calculation view is equivalent to calculation view is equivalent to multiple multi dimensions. Multiple multi dimensions. So multiple multi dimensions is a calculation view. Multiple multi dimensions. So it's a combination of multiple star schemas. It's a combination of multiple star schemas. Calculation view is very much flexible. So it's like you can have multiple tables, multiple tables, or multiple attribute views, multiple Okay, so a particular calculation view can have multiple tables, multiple attribute views, multiple analytical views, or multiple calculation views also can be multiple calculation views also can come into one calculation view. So a calculation view can be a combination of anything, and calculation view is highly volatile. And this type of view was never implemented in any of the softwares previously. It's a very flexible thing. So in most of the reports, we build upon the calculation views only. So a calculation view can be built using calculation view can be built on based on the GUI or the SQL based. Okay, it can be built on GUI or SQL. So either of these two, we can build it. So we have this calculation views. Is a combination of multiple tables, multiple attribute views, multiple analytical views, multiple calculation views using GUI process. Okay, I'm trying to get the server access, guys, this for this, so that we can, when we do this, we'll be understanding it better on the server. So let me just get the projects. First one is schema creation of a schema and schema table from flat file. This is the first project, guys. Okay, from flat file. So we'll be having a flat file, and the good thing is here you don't have to create the domains, data elements. You don't have to create the database tables. You don't even have to create anything. All that you have to do is you have to upload the file. System will automatically generate the field names. If you like the field names, you can keep it. Otherwise, you can change it. And data properties also will be assigned by the system only. And if you like it, you can keep it. Otherwise, you can change them. Okay, so that's how it is. Everything will be generated by the system. Okay, now in that way we'll do it. and those are called schema based tables from flat file. Automatic, automatic this is automatic, auto generated. Then we have the schema tables with schema tables with what you call from using from SQL language. We can write SQL code, and then we can manually create a table, manual creation, not the auto creation or manual creation of table. This also we can have. Then we have manual creation of table. We can do that, and then we'll go ahead with the uh, creation of attribute view, attribute views. Then we have creation of analytical views, creation of calculation views. So these all we'll be doing in the uh, HANA Studio perspective. Okay, these all we'll be doing in the HANA Studio perspective. Then we'll come to the ABAP perspective. In the ABAP perspective, we'll be creating the ABAP programs, DB tables. These are DB tables are very much pretty much same as we create in the normal program, guys. It's nothing new. CDS views is something which we need to understand. CDS views, and then we have AMDPs. AMDPs. So AMDPs we are going to create and we are going to consume that in the program. So these are the things that we have to do, guys. Like these are all simple things only, but we should be doing all these things like around 10 simple projects is what we have to do. So in fact, like calculation views we have to do multiple calculation views. Okay, analytical views we'll be doing multiple. So we'll be doing with single attribute view, multiple attribute views, and all this. Calculation view with single multiple. Again, we'll have the SQL based calculation views, and we'll have the um, SQL based, and we have graphical based, GUI based, graphical based. Okay, so these are two ways of creating a calculation views. We have ABAP programs, TB tables, and CDS views, and AMDPs. So these comes ABAP programs, TB tables, CDS views, and all these things come under the ABAP perspective. I've been trying many servers till now. I think in this the ABAP perspective is working, but the HANA Studio perspective is not working. So initial projects have to be done in the HANA Studio, but the ABAP perspective, whatever we have to do in the ABAP perspective. So in ABAP perspective, it's working. Okay, this server has an issue. Okay. So we'll go to the Windows perspective, this open perspectives, and ABAP perspective. When we go to the ABAP perspective, here we have created a project. So we created a project here. So this is working fine, and in this we should be doing all these activities. So we have to create a project here, and then in the project we have created a package, and in the package we created a program. So this is what we have done, but in the package we can do a lot of things here, which is what we have explored. So we open new other perspectives, and this will have lot of things here. Okay, so here we have authorizations, business objects platform, business objects, BSP library, business engineering classification, code connect, code composer, connectivity, and this core data services. See, this core data services, we are going to create views, guys. So these views are something which will be working on the database. So these views mostly work on the database. The load of these views is completely on the database. See, normally the views that we have created in normal ABAP, the entire processing will be done in the application server. So the whole load is on the application server, not on the database server. But when it comes to the CDS views, the entire load will be shifted to the database tab. So we are going to write this in the database tab. So all these days, let me tell you, all these days SAP did not allow anyone to create anything directly in the database. So let's say you have SAP software. In SAP software, what is the language that we are using right now? We are using the ABAP. ABAP as a coding language. So if you want to create a table, database table, you have to do it through the navigation. Okay, you have to go to S11 and create a navigation. Okay, you don't have the authorization, or you don't have the any access to create database table through writing the code. Okay, you can insert the data into the database tables using some logic, but you cannot have this. So that language is called DDL, data definition language. So data definition language is nothing but a language in which we are going to create new things in the backend. So we are going to write the logic and we are going to create. This was not available in the ABAP. Okay, the legacy ABAP that we have. We only had DML. Okay, DML stands for data manipulation language. Data manipulation language. So data manipulation language is nothing but you can edit, you can modify, you can delete, you can sort. These all things come under the DML. Okay, and then we have some DCL. DCL also is acceptable. DCL also will be available in the HANA Studio in the ABAP perspective, guys. But this DCL and DML, only DML is available in the old version. Old version we only had DML. We have data control language. So we'll write controlling. So who can access, who cannot access. For this also we can write a logic, and then we can stop them to access something, or you can give some access to someone to access something. So these all things will happen in the detail. So we have DDL, DML, and DCL. So in DML, data manipulation language was the old one. DDL, data definition language, is something new. It's not there till now. I mean, like only in HANA web it was introduced, and you can write this DDL code and DCL code only through this HANA Studio, guys. Only through this. You see, what happened? This program which we have created in the first half of the day, what we did, we just created this, and we saw in the normal AC38 it was there. So normal programs you can create either from the HANA Studio ABAP perspective, or from normal login also. But there are some DDL, data definition language. We cannot do it from the normal ABAP, we have to do it from the HANA Studio only. Okay, so here we'll go for this others, and here we'll create a CDS. I'm just showing you the sample, guys. Okay, so here we have the CDS, and then in the CDS we have data definition language. Okay, data definition. So this is DDL language. Okay, access control, data control language will be access control. Okay, so annotation definition, metadata extension, variants. These are normal things, but DDL, the data definition language, is very, very important for us. We'll be doing a couple of projects on the CDS views. Now, when we create a CDS view, it actually gets processed in the database layer. And what is the language that we are going to use here? We're going to use SQL language here, not the normal ABAP language. We are going to use SQL. So it will be very much similar to ABAP language with slight changes. I will show you that. ZDXC underscore CDS1, CDS1, CDS view. Next. Now here we are in the first half of the session, we created a request number, right? So we can make use of the same request number. I'm using the same request number here, and here it is showing that define view. Just let's say finish. Okay, this will give you some editing here. So what we'll do is we'll create a very simple view, guys. Very simple view. Okay, so here we'll give something like zdxc underscore CDS, but it can see this SQL view name cannot be same as the defined view name. Okay, so we need to change slightly. CDS1, I will get a CDS1. Okay, DXC underscore CDS1, or I'll give it a CDS DXC1, simple DXC1. So the SQL view name is DXC1. Okay, now here we will be, then view name is ZDXC1, which you already gave. Okay, select from. Can anyone of you tell any table name, some table name, standard table, standard database table?
So Mara table.
Mara table. Okay, so we'll take Mara table here. Now I'm writing Mara. So actually the view is used for joining the data from multiple tables, but just to understand the flow, I'm giving from only single table now. Okay, not two tables. I'm joining on getting from only single table. In this, we are getting the field names, and the field names we have to write here. So for this control space, if you write control space, we'll get the list of all the fields in the drop down. Okay, so I go for MATNR. It will come. See, I can select it from here. MATNR, comma. Then we have ERSDA, comma, ERNAM, comma, and do you have ERNAM is not there or what? ERNAM not coming. It actually shows in the space ERNAM, yes, it's there, and comma, ERS control space, you'll get this ERSDA, and then comma, POSN control space. If it's there, it will show. No, POSNR is not there in this, so it's not showing up. Then a okay, so we can also write some conditions in this, right? And it's a very simple CDS view now. which we are doing now with a single table, and we are giving the field names. If you observe here, we are saying define view definition. For definition, we are writing a code, guys. So after executing this, a CDS view gets created with these fields. Okay, as select from which table we are taking, we have to take it from some table, Mara table. We are taking it from the Mara table. What are the fields that we are taking? MATNR, AENAM, ERSDA. If you want to take few more, you can take it. You can take them. You can select it from this BSTR, BSTME, all these other fields. Okay. KUNNR. Okay, these are all fields we have. Now we'll just say okay, okay, syntactically correct. Then we'll activate it. Activation is successful. Then we'll execute it with this symbol run as an application server. Once we have done this, we'll be having the list of all the fields, guys. So this view that we have created now will be visible in the normal login as well. So we created a CDS view here, and this CDS view actually gets operate no matter how complicated code that you write in the CDS view, that gets processed in the server, in the database layer. Okay, it's not this server, I guess. I think it's 1909. It's not there in any of this. View. So we need to search in the view Z DXE star Z DXE1. ZDXE1 is the view that got created with all these fields. MANDT is by default added by the system, even though we have not added it. MATNR, ERNAM, ERSDA, KUNR are the fields. And if you have joined multiple tables, it would have been showed here in this screen. And then we have the selection conditions and all. So you can clearly see here that it's a what is the type of this view is a DDL SQL view. It's a DDL SQL view. Then we have the view fields. We have these fields. So this is what we have. Select this, execute. So these are the fields that we have. So these fields in these fields we have the data. So we have done it with single table. We can do it multiple tables, and we can also write the conditions. We can also have some average, and all these things also can be calculated. There are a lot of things that we can do, guys. Like we can do a lot of things in the CDS view level. So the advantage of CDS view is, instead of the CDS view getting executed in the application server, gets executed in the database layer, or the database tab. So that's a major thing, and it will reduce the load in the application tab. Completely focuses on the database tab. So it processes in the database tab. Okay. So we're going to create a few more things like that, guys. and we'll have something called AMDPs. So this serious view concept that we are creating, right? Serious view concept will have serious view concept and then serious view concept, and then we have the AMDPs concept.